This is the Sonic Systems microSCSI Ethernet adapter for the Macintosh.
Wait a second, did you just say Ethernet over SCSI?
Yes, Ethernet over SCSI. Let's talk about legacy network technology. I'm the Vintage Collector and these are my stories. During the early 1990s, adding Ethernet to an older computer was not always as simple as installing a network card. Many compact Macintosh models had no suitable expansion slot, and portable machines presented an even bigger problem. In the PC world, one popular solution were devices such as the Circum-Pocket Ethernet connected through the parallel port, giving laptops and compact systems network access without opening the case. Sonic Systems applied the same general idea to the Macintosh, but used the external SCSI bus instead. Normally, that port would be connected to hard drives, scanners or CD-ROM drives. With the correct driver, however, this little box turned it into a 10 megabit Ethernet interface. Sonic sold two versions, one for desktop Macintosh systems and another one for PowerBooks. The desktop model used the familiar DB25 SCSI connector, while the PowerBook package accommodated Apple's smaller portable SCSI connector. Despite using SCSI, this was not a universal adapter. Sonic Systems built it specifically for the Macintosh only, neither DOS nor Windows drivers have ever surfaced. So let's take a closer look at this interesting piece of hardware, generously donated by Peter from Germany. Many thanks to Peter for sending it in. And if you enjoy seeing unusual retro hardware like this put back into use, consider subscribing or becoming a channel member to support future episodes. To understand why an adapter like this was very useful, let's look at the Macintosh Classic II itself. We've explored other Macintosh systems in the past, such as the Macintosh SE30 and the Performer 450. Both had a processor direct slot, or PDS for short, which allowed to install internal expansion cards. The Macintosh Classic II, however, has no such expansion slot. In that respect, it followed the philosophy of the original 1984 Macintosh, which Steve Jobs had envisioned as a tightly integrated system without conventional expansion slots. And that is exactly where the microSCSI Ethernet adapter comes in. It connects externally to the Macintosh SCSI bus through a DB25 SCSI cable. Power is supplied separately from the ADB port using a pass-through power cable, so the port can still be used for keyboard and mouse. As with any SCSI device, you must ensure to assign it a free SCSI ID using this small rotary selector. This device supports both 10BASE-T and 10BASE-2 networks. There's no auto-sensing built in, so you'll have to use this small toggle here to switch between twisted pair or coaxial transceivers. I'll leave it on TP, twisted pair mode. With the hardware now connected, the next step is the software. But first, a quick word from PCBWay, who are celebrating their 12th anniversary with special offers on PCB manufacturing, assembly, CNC machining and 3D printing. You can also collect anniversary coupons worth up to $435. Check the link in the description for all the details. Now, let's install the EtherLAN drivers. The driver disk also includes a diagnostics utility, which confirms whether the device has been detected correctly. It also appears in general SCSI utilities such as SCSI Probe. Since I'm not currently providing Apple Talk over Ethernet, I installed MacTCP so the Macintosh could connect using TCP/IP instead. That should have been straightforward, hadn't it been for the fact that I seemed to be unable to send out ICMP pings reliably. At best, only the first ping went through, with subsequent ones timing out. Interestingly enough, I had no issues in pinging the Macintosh from another host on the network. Uploads and downloads over FTP work perfectly well, with solid transfer rates of around 400 kilobits per second. The microSCSI adapter operates at 10 megabits per second in half-duplex mode. To rule out a negotiation problem with my modern gigabit switch, I placed an ordinary Ethernet hub in between the Macintosh Classic and the switch. That made no difference. Next, I ran Wireshark on my modern MacBook to check whether the ICMP echo requests were actually arriving. And they were. One unusual detail was that MacTCPPing did not appear to increment the ICMP sequence number. Every request seemed to use the same value. The packets sent by the Classic II were also only 60 bytes long, compared with the 98-byte packets generated by the ping utility on my MacBook. That difference is not necessarily a problem, since ICMP-ping can use different payload sizes. Pinging the Classic II from the MacBook produced no packet loss, although the reported round-trip times showed considerable variance. I then increased the ICMP payload in MacTCPPing to 1472 bytes. Together with the 20-byte IPv4 header and the 8-byte ICMP header, that produces a complete 1500-byte IP packet, which fits inside a standard Ethernet frame without fragmentation. Wireshark correctly captured these as 1514-byte Ethernet frames, excluding the 4-byte frame check sequence. Again, all requests arrived just fine on the MacBook. And on the classic Mac, MacTCPPing now displayed receiving echo replies, even though it still occasionally failed to register one or another. As far as this is concerned, I have not observed this particular behavior on Macintosh systems using PDS-based Ethernet adapters. My best guess is that MacTCPPing has difficulty matching or processing the replies, possibly because it does not use ICMP sequence numbers. And because of not using such sequence numbers, it can't correctly match the echo replies with the echo requests. I assume this is caused by general timing issues specific to the microSCSI adapter, potentially made worse by the relatively slow processor in the Macintosh Classic II. But as general connectivity works and FTP transfers are reliable, this does not appear to be a serious network problem. A useful follow-up would be to test the adapter on a faster Macintosh or replace MacTCP with Open Transport. That could reveal whether this is a MacTCP implementation issue or simply a consequence of the system's overall performance. So, the microSCSI Ethernet adapter was unusual but not quite as strange as it first appears. SCSI was never limited to just storage. Scanners, cameras and other peripherals also used it, and Sonic systems simply pushed the idea further by turning the SCSI bus into a network interface. With reported prices between $399 and $499 for the desktop and PowerBook versions, these adapters were not particularly cheap, although they significantly dropped later on. Other companies such as Dana and Farallon, just to name a few, also offered similar external Ethernet adapters. Sonic Systems later moved away from Macintosh networking hardware and eventually became Sonic Wall, best known for its network security products. What about you? Did you ever use one of these SCSI Ethernet adapters on the Macintosh, or perhaps a parallel port pocket adapter on a PC? Let me know in the comments below. I'm the Vintage Collector, and this was my story for today. Thanks for watching, and see you again next Sunday.